Hey guys, so today I'm just going to be teaching you about Punnett squares. So what is a Punnett square? A Punnett square is a model used to predict possible genotypes and phenotypes of an offspring. So we're just going to start off with how to set up a Punnett square. Okay, so when setting up your Punnett square, there's a few things you have to remember. So on top, you always put your male alleles and on the left side you always put your female alleles. So the one that I'm going to be showing you today, we're going to do two yellow peas. So we put capital Y, lowercase y, and that one is a yellow pea. And then our female allele is also a yellow pea. Oh my gosh. So we have capital Y and a lowercase y. That one's also a yellow pea. And so one thing we always have to remember is that you always list the dominant trait first. So you always do the dominant trait first. And then the male is always on the top and the female is always on the left side. So when we actually go to fill out our Punnett square, we're going to start in the top left corner. And as we can see, we have a capital Y and another capital Y. So that's what we get. Capital Y, capital Y. And then we go on to the next one. We can see we have a capital Y and a lowercase y. And you always put the dominant first. And the dominant will be the capitalized letter. So we get capital Y, lowercase y. And then for this one, we can see we have a capital Y and a lowercase y. And for our last one, we can see we have a lowercase and a lowercase. Oh gosh. So then how you would label that is this would be a yellow pea, yellow pea, yellow pea. And then since this one has no dominant letter in it, this one is actually going to be a green pea. So when you figure out your Punnett square, you can find the ratio for the peas. For our phenotype, we are going to have a 3-to-1 ratio because we have 3 and then 1, so 3-to-1. And then our genotype, oh gosh, is going to be 1 to 2 to 1 because we have one of the two capitals, two dominants. We have 2 of the one dominant, one non-dominant, and then we have one where it doesn't have any dominant at all. So that's going to be a 1 to 2 to 1 ratio for the genotype. So I'll have you guys try this one first. This one's pretty simple, but this one's an example of where both parents have 2 dominant alleles instead of 1 dominant and 1 non-dominant. So go ahead and try this one first. So once you guys have done this one, so you'd end up with dominant A, 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 and dominant A. So all of them would all be dominant. So your phenotype and genotype would both be a 4 to 0 ratio. And then I'll have you guys do this one next. This one an example of where the father has 1 dominant and 1 non-dominant, and the mother has 2 non-dominants. So what this one would end up being is you'd have a dominant B, lowercase b, lowercase b, lowercase b, dominant B, lowercase b, lowercase b, lowercase b. So your phenotype would be a 2 to 2 ratio because you'd have 2 with the dominant allele and 2 with both non-dominants. And then your genotype would also be a 2 to 2 ratio because you'd have 2 with a dominant B, lowercase b, and 2 with 2 non-dominant lowercase b's.